Imagine a world where energy never runs out, where power is available 24/7 without polluting the planet. A world where we tap into the Earth's natural heat to generate electricity, heat homes, and drive industries, all without burning fossil fuels. This isn't science fiction. It's geothermal energy, one of the most underutilized yet powerful renewable energy sources available today. In this discussion, we'll dive deep into what geothermal energy is, how it works, its advantages, limitations, and why it holds immense potential in shaping the sustainable future. What is geothermal energy? Geothermal energy is the heat stored beneath the Earth's surface. The word geothermal originates from the Greek words geo, earth, and therm, heat. This energy comes from two primary sources: the heat left over from the planet's formation 4.5 billion years ago, and the ongoing decay of radioactive elements in the Earth's core. At the heart of our planet, temperatures can soar up to 5,500 degrees Celsius, as hot as the surface of the sun. This intense heat gradually radiates outward, warming rocks, groundwater, and other materials beneath the Earth's crust. In some areas, this heat is close enough to the surface to be harnessed directly for human use. There are two main ways we utilize geothermal energy. Direct use. Hot water from geothermal reservoirs is used directly for heating buildings, greenhouses, and even melting snow on roads in colder climates. Electricity generation. Steam or hot water from beneath the Earth's surface is used to spin turbines, producing electricity in geothermal power plants. Unlike solar and wind energy, which depend on external factors like weather conditions, geothermal energy is always available, making it a highly reliable renewable energy source. How does geothermal energy work? To harness geothermal energy efficiently, we tap into geothermal reservoirs, which are areas where heat is trapped beneath the Earth's surface. These reservoirs exist in volcanic regions, tectonic plate boundaries, and areas with naturally occurring hot springs and geysers. There are three main types of geothermal power plants. Dry steam plants, the oldest and simplest type. These plants use natural underground steam to turn turbines, generating electricity directly. Flash steam plants, the most common type today. High-pressure hot water is extracted from underground, and as it reaches the surface, the pressure drops, causing the water to flash into steam, which drives the turbine. Binary cycle plants, used for lower temperature geothermal resources. These plants transfer heat from underground water to a secondary liquid with a lower boiling point, which vaporizes and spins the turbine. To access geothermal energy, deep wells, often few kilometers deep, are drilled into the Earth's crust to reach these underground heat sources. Once tapped, geothermal energy provides a continuous and renewable supply of power. The benefits of geothermal energy. Geothermal energy has significant advantages that make it a key player in the transition to a cleaner energy future. Sustainable and renewable. Unlike fossil fuels, geothermal energy does not deplete over time as long as the reservoirs are managed properly. The Earth's internal heat is practically inexhaustible on a human timescale. Low carbon footprint. Geothermal power plants emit very little carbon dioxide, significantly less than coal, oil, or gas-powered plants. This makes it a clean and environmentally friendly alternative to fossil fuels. Reliable and consistent. Unlike solar and wind, which depend on the weather, geothermal energy is available 24/7. This makes it an excellent baseload energy source, providing a constant supply of electricity regardless of external conditions. Efficient land use. Geothermal power plants take up far less space than wind or solar farms. A single geothermal plant can generate as much electricity as hundreds of acres of solar panels or wind turbines, while maintaining a smaller ecological footprint. Multi-use applications. Geothermal energy isn't just for electricity generation. It's also used for heating and cooling buildings, providing heat for industrial processes, growing crops in greenhouses, balneotherapy, therapeutic hot spring baths, Long operational lifespan. Geothermal power plants have long lifespans, often exceeding 30 to 50 years with minimal maintenance. This makes them a cost-effective energy investment over time. Challenges and limitations of geothermal energy. Despite its many benefits, geothermal energy faces several challenges that limit its widespread adoption. Location dependent. Not every region has easily accessible geothermal energy. The best sites are typically found near tectonic plate boundaries, volcanic areas, or hotspots, making it difficult for countries without these natural conditions to harness geothermal power efficiently. High initial costs. The exploration, drilling, and development of geothermal power plants require significant upfront investments. Drilling wells can be risky and expensive, especially if an adequate heat source isn't found immediately. Environmental concerns. While cleaner than fossil fuels, geothermal energy still has some environmental risks. Water contamination. Geothermal fluids contain trace amounts of minerals and gases that, if not handled properly, can contaminate groundwater. Induced seismic activity. In rare cases, injecting fluids into geothermal reservoirs can trigger small earthquakes, a phenomenon known as induced seismicity. Heat depletion. In some cases, geothermal reservoirs can cool down if too much heat is extracted too quickly. Careful management and reinjection of fluids help maintain the reservoir's long-term viability. Public perception and awareness. Many people are still unfamiliar with geothermal energy, and governments may prioritize more well-known renewables like solar and wind. More education and awareness efforts are needed to promote geothermal development. Global impact. Geothermal energy around the world. Several countries have already embraced geothermal energy as a significant part of their power supply. Iceland, a world leader in geothermal energy, Iceland generates 90% of its heating and 25% of its electricity from geothermal sources. United States, the largest producer of geothermal electricity, with major plants in California, Nevada, and Hawaii. Kenya, a leader in Africa, with the Olkaria geothermal plant supplying nearly 50% of Kenya's electricity. Philippines, the second largest geothermal energy producer in the world, heavily relying on geothermal power to reduce fossil fuel dependency. These countries demonstrate that geothermal energy is a viable solution for a cleaner and more sustainable energy future. The future of geothermal energy. As technology advances, new innovations are making geothermal energy more accessible and efficient. Enhanced geothermal systems. A revolutionary technology that creates artificial geothermal reservoirs in areas without natural hotspots, vastly expanding the potential of geothermal energy. Deep drilling technologies. New drilling techniques allow us to reach hotter and deeper geothermal sources, unlocking more energy potential. Hybrid renewable systems. Geothermal is increasingly being paired with solar and wind to create reliable 24/7 renewable energy systems. The International Renewable Energy Agency estimates that geothermal energy could provide up to 8.3% of the world's electricity by 2050 if investments and research continue at current rates. Governments, businesses, and scientists must work together to scale up geothermal technology, reduce costs, and expand access. With the right policies, geothermal energy can become a cornerstone of a global, carbon-free energy future. Future market forecast for geothermal energy. The future of geothermal energy looks promising, with significant growth projected in the coming decades. According to industry reports, the global geothermal energy market is expected to grow at a compound annual growth rate of around 5 to 9% from 2023 to 2030, driven by increasing demand for clean, reliable, and baseload renewable energy. By 2030, the market size is anticipated to reach $9 to $12 billion, with key contributions from power generation, direct use applications, and geothermal heat pumps. Regions like North America, Europe, and Asia Pacific are leading the charge, with countries such as the United States, Indonesia, Kenya, and Iceland, investing heavily in geothermal infrastructure. Technological advancements, such as enhanced geothermal systems and binary cycle power plants, are also expected to unlock new opportunities, making geothermal energy more accessible and cost-effective. As the world transitions to a low-carbon economy, geothermal energy is poised to play a critical role in meeting global energy demands while reducing greenhouse gas emissions. Conclusion: geothermal energy, a key to sustainability. Geothermal energy is one of the most promising solutions for a clean, reliable, and sustainable future. By tapping into the Earth's natural heat, we can reduce carbon emissions, decrease reliance on fossil fuels, and create a more resilient energy system. As awareness grows and technology advances, geothermal energy has the potential to become a major player in the global transition to renewable energy. The question is, will we invest in this hidden powerhouse or continue relying on energy sources that harm our planet? The choice is ours. If you found this insightful, hit the like button, subscribe, and share to spread the word about clean energy solutions. Thanks for watching, and see you in the next one.